Okay, so Ohio gozaimasu. あなたたちの日本英語は私の日本語より上手です。So today, let's do it in English. And I'm sure everyone speaks hopefully better English than my Japanese. So I have plenty of things in the slides that are hard to write down. So the slides are uploaded, or you can get them from here. Sometimes you'll see a short link, and that's just the easier way if you want to write it down. There's only a few characters. Of course, mostly for big pictures. Feel free to interrupt me if I'm not going too fast. You can't hear me. I'm not making any sense. Don't be shy. So, Btrfs. Should be fine. Okay. So, first question: who here has used Btrfs or tried Btrfs? 2, 3, 3 brave people. Okay. So, while we talk about Btrfs, I didn't write Btrfs. I just contributed a little bit of best use practices and scripts to use with it. But I went to a Btrfs talk about 2 years ago in Australia, and I realized, hey, this really does what I want. I really wanted snapshots. If some of you have used snapshots, either using the ones built in the LVM layer, or using network appliance servers or other ways to get snapshots, it's a really good way to go back in time and say, hey, I want my file from an hour ago, or I deleted my file and I really didn't need it. Sometimes you want to diff a file between now and a week ago. So you use snapshots back in time, and you can do that easily. But with LVM, it's really slow. If you use LVM snapshots on Linux, they're really meant to be doing a backup and then you delete the snapshot because the performance is really bad. So I tried to use them in the past, but it was just painful enough that we didn't use it much. And now we're back to one snapshot, which is exactly what Btrfs offered, among other things. Now, 2 years ago, Btrfs was still a little bit more new than it is today, but it was still already usable. Actually, I can't say I have really lost much data with Btrfs without doing stupid things on my side. So why would you consider Btrfs not counting snapshots? So Btrfs uses copy on write and atomic transactions. So every bit is written, it's wrapping a journal. It actually writes every bit of file in an atomic way. And that way you get better performance and better recovery. The snapshots we talked about. Then blocks can be assigned to different files. So copy reflink actually lets you copy a file to a different file, sharing the same blocks. And then if you modify some of the blocks, the rest are still shared. So it's better than having a hard link. And the other part that's important is the metadata, which is the file names, the directory structure. That's redundant by default, even with one disk. And everything is checksum. So not only the metadata is checksum, but also the data blocks. So if you have data corruption on your disk, or maybe an SSD, you will be able to find out. And ext4 does actually have patches to do that, but it's not there by default. Other things in Btrfs are built-in RAID 0.1 support. You don't need to use a different layer for that. RAID 5 and 6 are available, but they're not fully finished, so they work, but recovery doesn't fully work in all cases yet. So if you pull the drive while it's working and try to rebuild, it gets complicated. As I mentioned, you don't need to use LVM anymore. The fewer layers you have, the better it is. It has a file compression. You have 2 levels of compression. LZO is the faster one. ZLib is the better one, it's a bit slower. Another thing I really like is it has a scrap, which basically, it's not quite FSCK, it doesn't check everything, but it will scan all your data blocks and make sure the checksums are correct. And if you have metadata that's been corrupted because it has 2 copies, it's able to fix the bad copy using the good one. So it's kind of having a RAID 1, but you only have 1 drive, so it's kind of nice. Then we'll talk more in details later. but the block file system diff between snapshots is actually, for me, a killer feature. And one of the things the title was doing file system syncs using that. So I'll go into more details on that. And Btrfs converts, I look at it as a toy, but it's still nice. You can actually convert an ext3 file system to Btrfs on the fly. Sometimes it works even. I would just say do a backup, because it's like every file system you kind of want to have a fresh, clean file system. The next question you may have wanted to ask, which is ZFS. Btrfs does a lot of what ZFS does. Or putting it another way, ZFS was already there. Why not use ZFS? It is more mature. It's been there for almost, actually, over 10 years now. But at the time, it was part of Solaris, and it was licensed to be incompatible with Linux. And I think that was not exactly a mistake. And it's also very memory hungry. So it's the way it plugs into Linux. It doesn't share the memory, and it's basically suitable to a very big server where you can just say, hey, all the memories for ZFS, or a lot of it is, but it's not that great on a laptop, for instance. But the bigger problem with ZFS is the licensing issue, because memory, it's reasonably cheap. Licensing, however, is more of a problem. So Oracle bought Sun. So now they own all the patents and the ZFS code. And they could relicense ZFS under either GPL2 if they wanted to. They also have to worry about things that were contributed by other people. But that's a solvable problem. So the question I asked myself was, why would Oracle sponsor Btrfs to rewrite an entire file system when it already has ZFS and it could relicense it? And that really bothered me for a while, because I couldn't make sense of that. So yes, patents. So I mentioned network appliance, NetApp, in a few slides. And NetApp had copy on write first a long time ago. And basically, NetApp sued Sun at the time, saying, hey, we have patents on ZFS. That said, as the slide says, it's not actually NetApp being the bad person. Sun actually attacked NetApp on something else, and NetApp said, hey, wait a minute. We have patents on your stuff too, and then start shooting one another. That was always how it works. Nobody wins. Right around that time, Apple also thought, hey, ZFS is pretty cool. And it's like, oh, maybe we don't need to use it anymore. And they wrote their own file system. So it looks like the patent problem from NetApp was definitely an issue. So the fact that Oracle starts, sponsoring Btrfs with Chris Mason at the time, probably is not exactly an accident. Now, Chris says, it was designed to not infringe on patents as far as he knows. But if you know, well, you may not know, but the patent law in the US is kind of stupid. If you know of a patent and you infringe it, you have to pay 3 times as much money as damages. So what people do is they don't read patents, so that they divided them, they can say, well, I didn't know. So you only pay 1 time the damages. Makes perfect sense. Anyway, NetApp and Oracle agreed to end the suit, saying, okay, maybe we're all going to lose in this. So they had an undisclosed agreement, and they stopped suing one another. But that's also the time that Oracle stopped caring about ZFS. So is it a coincidence? I don't know. That said, Oracle actually has an official answer. I can let you read it in more details. But they have apparently other issues with ZFS that they want to just rewrite a new file system to fix. So at the end of the day, it doesn't really matter. The position right now is that ZFS will never get into the Linux kernel because of its current license. And that's why I'm actually, warning people. I mean, it's a really nice file system. I am not trashing ZFS, but you will have to patch it into the kernel forever. If you build an appliance and you want to sell it to customers, you will not be able to, because the license incompatibility will prevent you from doing that. So unless you want to play on your own file server, it's probably not a good idea to use it. So back to Btrfs. So Btrfs, you always hear, it's a really nice file system. When it's ready, it will be really nice. maybe I'll use it like next year. So that's what you hear every year. So Btrfs has a lot of features. Some are newer and they're not as stable, but the core features have been around for quite a while, and those are actually working pretty well. Now, if you follow the new kernels of each release, they do change things, and once in a while a bug kicks in, so you may not want to take the latest RC kernel that just came out, unless you're just doing testing. But overall, it works well. So the things that are stable are snapshots. That's the bread and butter. It works really well. Grade 0 is grade 1. That's pretty good too. Corruption problems I've been using for about 2 years. I've only had a problem once with it that was unexplained. But it was on my laptop with an SSD, so there could be plenty of other reasons why I have corruption. It may not be the file system. You always blame the file system, but really it could be something else. And the long story short is you always should have backups. I'll get back to backups later. But when you're using the features, just look at the basic features, test them for your environment, and those work pretty well. You don't just change the kernel all the time for unstable stuff. There are a few quirks though. One of them is balancing. From time to time, some workloads can get the file system out of balance and it needs to be rebalanced, which can be done online. We'll get into that later. Also, it has an auto defragmentation feature, which had a few issues. I think it got turned off recently. Btrfs then receive is the snapshot diff. We'll talk about that more later. That works pretty well. Sometimes it gets stuck and you don't get corruption, you just get an error and then you have to fix it manually. But overall, it works well. Grade 5 and 6, those are definitely more for testing. I wouldn't put any real data on it yet. What's missing? So you may have read that, oh, Btrfs doesn't have FSCK. I don't want to use a file system without FSCK. Well, actually, it's a reasonable thing to say. But turns out that FSCK on Btrfs is not as useful. And the reasons are, first of all, it is self-healing because it has copies of metadata. It knows, and if there are checksums, it knows if there's a copy that got corrupted, so it can fix itself. Scribe, and we're going to describe later, will take care of that for you. But you know, there could be bad things like a drive failure, like 4 blocks that disappeared, an SSD that corrupted your data. So in that case, it could come in handy, and there are a few ways to do recovery. File encryption is the one I actually wish were there. There is no encryption support, so you have to use dencrypt. So you do the dencrypt layer first, and then you put Btrfs on top. Dedupe is block deduping, that is present in ZFS. There is support for it, but the automatic mode doesn't work yet. It's just a script that you can run, and it will find blocks and then put them together. So it's a little bit early still. But the support is there, so if it's something that's important to you, you can expect they will be there sooner than later. And then it's missing more brave users like you with expandable data. So, who works on Btrfs? So I can see the list of companies that listed for run, and would be happy to have your company name there. Fujitsu is the winner in Japan right now. Who uses Btrfs in production? So that not many companies are talking about using it in production yet. There's a few. The first link you can go read there to see a list. But there's actually like 2 main websites that are tracking file systems that are both planning for Btrfs to start growing in usage this year and to start going in production. There will probably be limited production and some set of features, but still. Alright, so I hopefully convinced everyone now. So we'll look at best practices and several things that are special about Btrfs if you come from the ext4 world. So maybe it's bad to start with recovery, but some people are always worried about that. I thought I would start with that bit. So again, the blue links, they have a lot more details than the slides have, so you can go to them later. But the first thing I mentioned was Scrub. Scrub is something you can run at night or when you have low load, and it will basically read all your blocks and check all the checksums, and if it has a copy, because it's grade 1, it will fix it. If it doesn't have a copy, it will put a syslog, hey, this block is corrupted. So sure, you lost data, but you know exactly what file you lost, and that's important. The other things you can do it in the background. You don't have to unlock your file system like you would with FSDK. That's a very nice feature. The next ways to recover is if a file system is very corrupted, well, somewhat corrupted, you can mount it read-only with a recovery flag, which will actually bypass some checks and let you mount a file system that would not otherwise mount properly. Then zero log, I mentioned Btrfs copies blocks in sequence, and if the last blocks have bad data in them, maybe the file system will not mount because it doesn't make any sense. So zero log will basically delete that last little bit that is all corrupted, and you can then mount the file system at the previous state, which is only maybe one file lost or something like that. So it's not unlike FSCK, but it's a lot faster because it doesn't have to scan the full file system, it just needs to know the last bit is the bad bit. Btrfs restore actually can open a disk image, and it will poke and find files in it and copy them somewhere else. So it doesn't modify the file system or making it worse, it just gets all the data out as much as it can. And then check repair, which is also the FSCK tool, is the last one. It is an incomplete FSCK tool. It will do some work. It will also tell you if you have corruption or no corruption. It won't fix everything, but it will actually fix, hopefully, most things. That said, backups. I'll repeat that later. So I mentioned scrub earlier. Let me see if there's anything I didn't mention already on the slide. No, I did everything there. So if you look at the last link, I have actually a script that launches a scrub. It runs syslog and it finds all the syslog entries that are relevant and then emails them to you, so you can know exactly what went wrong. Because usually you don't go to checking syslog until you already know you have a problem. There's one little bug in scrub, so you don't have to remember this slide. The bold bit over there is the important part. Sometimes scrub, let's say you turn off your machine in the middle, it doesn't keep track of the fact that it stopped running, so you have to stop manually by just saying finished equals 1 in there. It's a little bit silly, it's a bug for now, it will get fixed eventually, but that will save you some time if you get into that state. Alright, so we talked about layers and LVM and encryption and so forth. So, if you want to use RAID, as I mentioned, RAID 0, RAID 1, they're actually okay to use in Btrfs. RAID 5, RAID 6, not quite yet, I would say. So in that case, you would use software RAID. If you use software RAID, it's pretty simple. You end up with one device, and if you want to encrypt it, you have the question of, do you encrypt all the devices first and then put software RAID on top, or do you put software RAID and then you encrypt the result on top? And it actually works better if you encrypt the result on top, because you only have to decrypt one device, which is easier when you mount it. But also you only encrypt n-1 drives of data. You don't have to encrypt the priority drive when you're thinking about I/O. Now, if you are using the built-in RAID, then you don't have software RAID giving you one nice device. You have all those drives that you need to encrypt first, and then you make them part of a Btrfs file system. So the way it works is you first have to decrypt all the drives, then you do Btrfs scan, which will rescan everything, and it will see, oh, I have new devices, and it can see the label, it can see those drives belong together, so it does all that work for you. And then you can mount it through two ways. The first one is you can give the label of your file system. The other one is you can just give any of the devices. So if you have 5 devices, you just give the first one, the 4th, it doesn't matter, and it says, oh, okay, that's the file system you want. Then it knows the UID of the file system, and it knows how to find the other devices. So you don't have to give all the devices on the command line. That's automatic. And I have a script that does that if you want to look at how to do it more quickly. Now, what's different in Btrfs is the concept of pool. You don't really need to create partitions anymore. You just have a one big storage pool, and then in that pool you create subvolumes. And those subvolumes is what you would use to have as partitions. But the thing is, they share the same pool of blocks. So there's two things you gain from that is, of course, you have immediate resizing. If you use quotas, you can say that that subvolume is not going to get bigger than a certain value. And then you can share blocks between subvolumes, and that's the pretty cool part. Now, the way you mount subvolumes, so this is how you create them and so forth. The way you mount them is when you mount it, this is your device node. The subvolume here is just the name of, it looks like a directory in ls, but for Btrfs it is a subvolume. So you say, hey, I want the subvolume root in the device SDA1. And that's how it mounts your root file system. Then if you do it by hand, you can say, hey, mount subvolume user, and then that's the mount point it goes to. And a third way of doing it is if you mount, and that's what I recommend doing, a pool in a mount point where you can see everything, you can do a bind mount of this subvolume into the destination. So, we talked about snapshots a little bit. So snapshots work on a subvolume level. And that's why you also want to use subvolumes. It's not just a nice thing, you really, really should use subvolumes in Btrfs. So snapshots are very flexible. You can snapshot a snapshot, you can make a read-only snapshot or a read-write snapshot, you can go the other way around. It's pretty flexible. So this is how you create a subvolume. Then if I create a file in it, and I snapshot into a different subvolume, so that's here. If I touch a different file, and I delete the original file in the original subvolume, the backup subvolume still has both files. I mean, it's pretty basic, but it shows you how that works. Then, if you want to show the subvolumes to see their data, you can see that the main subvolume here has a list of all the snapshots that have been taken. Here there's only one. And if I look at that subvolume, that snapshot of the first one, it will show me the parent UID, so it tells me, hey, I'm a snapshot of this, which is indeed this one up here. Used to that. So even with ReadTime, which is the default on Linux now, it still rewrites the file at least once a day to update the access time. So if you use Btrfs, unless you really, really, really need A time, which you probably do not, just turn it off. You'll get much better performance out of it. Alright, so the next issue that you will probably run into that's a bit more different on Btrfs is running out of space. So that's a Btrfs FIS file system show. So it shows you two numbers. It shows you that right now my file system is using 214 gigabytes out of 231, but it also shows me that that device is actually using all the space. So even though I still have 20 gigs free, because of balancing issues, it's not necessarily able to find new blocks. That's arguably a bug. It will have to be fixed, but it's not that simple. So the two things with Btrfs is you probably don't want to fill up the file system entirely if you can avoid it, so leave a bit of room. The other thing is if you hit that, you will need to do some rebalance, and we'll get into that later. In this case though, I'm pretty full, so the quickest thing you can do if you have snapshots is you go back and you delete all those snapshots. And that way you free space. But the reason I have bold here is it actually takes a few minutes to do garbage collection. So even though you just deleted a lot of snapshots, you say, hey, I didn't get my space back. It's because for performance reasons, the command works right away, and then it goes in the background to clean those blocks, and that can take 10 seconds, 30 seconds, maybe a minute or more. So if you delete snapshots, be patient. You can just run that FI command in a loop every minute, and you will see that number going down over time. The other issue is if you just created a big file and you deleted the old one, now you have two copies of that file in the one that's current and the one that's in all your snapshots. If that happens, you have really no choice but deleting all your snapshots. Or you can go in all the snapshots and find that big file and manually delete it. That's the only way to get free space back. At least on Btrfs, you can individually delete files in snapshots because they're writable. The other thing I mentioned was, yes, I ran out of space, but really I have actually space left. And that's the problem I mentioned, where there are times where it gets out of balance. I'm not going to go into long details, I'm just telling you that it can happen. You can go here and there, which effectively explain how to run a balance command that will go back and reorganize blocks, and that's without unmounting. And then you will get more space back. It's a bit unfortunate. That's one of the things that will get improved. But if you do hit it, then you know what to do. I mentioned compression. You have two kinds. I would say LZO is faster, zlib is actually better. If you have a hard drive, zlib is probably quite fine. I tend to use LZO on SSDs because SSDs are very fast. And then compression is something you can change after the fact. So you can, every time you mount your file system, say whether you want new files to be compressed with one or the other. And you even have a way to say, hey, rewrite all the files to be recompressed with the new compression that I just chose. So block deduplication, I did mention that very quickly. That's the URL to the script that lets you do this. It's still, I wouldn't say it's fully experimental, but it's still not production ready, I would say. So it's something you can try. But the one function that is usable right now is you can use reflink. And reflink means when you're copying a file, you're just copying the metadata, but then both files are pointing to the same data. And that sounds just like a hard link, except the destination can have a different permission, a different owner, and if you modify that file, only the modified blocks will be duplicated, which is a lot better than a hard link. The other part I mentioned earlier is you can do a copy across subvolumes. So imagine having two different partitions. You can actually have two files in two partitions that are sharing the same data blocks. And that's quite nice. So Btrfs send receive. And that's, in my opinion, the killer feature in Btrfs. The way it works is basically you make two snapshots. You have a read-only snapshot, and when you make a new snapshot, you can tell, well actually that's the first copy here, sorry. The first time it just copies everything. The second time you say, hey, look at all the blocks that are different between those two snapshots, and it will only send those blocks to the other side, and then update the destination. And that is so much faster than using rsync. If you have millions of files, using rsync would take 10 minutes more to check all those files one by one. Whereas this is pretty much, it knows what blocks change and it knows what to send. So yes, I'm just putting the backup thing here over and over again. Hopefully I'll get into everyone's heads. So now how do you do historical backups? There's different ways of doing it. The first one is you put a subvolume, and then you can do a snapshot and rsync to that snapshot, which means that only the blocks that changed will be modified. That's an easy way to do it. You're using built-in features, and it will be fine. The only problem is that you cannot hard link different files easily, so you cannot use a hard linker between that snapshots because they are subvolumes. You can only use reflink, and that's a little bit complicated. Basically, reflink is really built in Btrfs, so it can go across subvolumes, whereas hard links cannot cross subvolume boundaries. The next way would be to just use hard links, which is the way you would do it today with the ext4. You just create a tree, you make a hard link of all the files into a new tree, and you rsync on top of that. And if you do that, that works fine. But if blocks get modified, then it copies the entire file, and then you have two copies of the file. But you know, it works. The better way with Btrfs is now, of course, to use reflink, and that's the one that copies the file and only modifies the blocks that have been modified, not everything. The one problem with reflink, and the reason why I'm not a big fan in all users, is that you don't have a good way to know that those files are sharing the same blocks after the fact. So if you use star, or if you use CP, or any way to copy this somewhere else, it will lose that relationship of those files being tied in together. The only way to keep that relationship is to use Btrfs send, but anything else will lose, and then they will copy the data twice. That's why sometimes using the hard link solution could be better. All right, defragmentation. Because the way Btrfs lays out blocks, if you have a big disk image, every time you modify a disk image, it will, right in the middle of the file, the blocks that got modified. But Btrfs does not go and rewrite in the middle. It just keeps writing new blocks like this, and then it ends up freeing the blocks in the middle. So it doesn't. That's how it does its journaling. It's always in a consistent state. But if you do that, you have now all those little blocks empty in the middle, and all those new blocks at the end that keep going, and you end up with a lot of Swiss cheese. So you have a feature, and you see its attribute here, to say, hey, everything in that path, or just that one file, please do not use copy on write. And you do want to use this if you have a disk image or a database that gets rewritten in the middle. Without that, you will just end up with a very fragmented file. Now, you do have defragmentation, and that's shown here. But as a warning, I had a 70 gig image of a file system, and it took a long time. So it's not very intuitive, but you're actually better off copying that file into a new file than defragmenting it, which is, yeah, it doesn't make sense, but that's the way it is for now. Alright, so I talked about RAID 0 and RAID 1. What's very interesting with Btrfs is that you can give a different RAID level for the metadata and the data. And you may ask yourself, why? Well, so you can actually say, hey, I want my metadata to be RAID 1, but my data is okay if it's only RAID 0. Another way of using it is, if you have blocks that are across 2 drives, instead of saying RAID 0, you can say single, which tends to lay out files more on one drive than the other. So you don't get the throughput of writing in parallel on both drives, but you get more files are laid out more evenly. That's really more important if you're using one drive and you're doing recovery. Then the other ones are obvious, so of course you can do RAID 1 on both. And you can also do things like RAID 1 for metadata and RAID 5 for blocks. But the thing that's not very intuitive is that RAID 1 does not mean copy the data on all the drives. It means copy the data on 2 drives. And Btrfs will choose 2 drives, however it wants, and make sure that your data is there twice. The interesting thing about Btrfs is you can do on-the-fly conversion. You can say, hey, I have RAID 1 right now. I'm adding 2 more drives. Please make it RAID 5. And that's actually pretty cool. You can also go backwards. That sounds insane, but you actually can't do that. It will take a long time because you have to write all the data blocks and relay out everything. So it could take hours, it could even take a day if you have a terabyte file system. But the point is, it can do that. I mentioned earlier RAID 5 and RAID 6. Recovery doesn't quite work. Scrub can now deal with issues and fix them. So it's there. The last link here shows you exactly how it works. You can actually pull a drive and rebuild, but you have to know how to do it. So the last bit I actually want to emphasize was, I don't know if any of you were here for my talk last year on how I explained how we do file system syncs to all our servers at Google. The long story short is, if we have servers and you want to upgrade them, I was explaining that you're better off syncing on a file-by-file basis to all your machines and going on each machine and saying apt-get upgrade or yarn update. And the way we do that is we have a custom daemon that's rsync-like that does slow I/O so that it doesn't impact each machine. And that's how we sync updates to all those machines. Now, that daemon, unfortunately, is not open source, and rsync is pretty heavy in how it does things. It really slows down your server and your client. So it's really not the right way of doing it, but that's what we had 12 years ago, so that's what we did back then. The whole point, though, is that with Btrfs, you don't need to be doing this anymore. You should never have to use rsync to find the difference between 2 file systems. You can use snapshots and say, hey, that's my file system. This is the new one I'm trying to push. It will compute the difference between those two very quickly, and it will just sync those blocks to the destination. So you have to juggle snapshots a little bit and say, this is the new snapshot. The simplest way is to then, if you have a server that boots quickly, to just move your pointer to the new snapshot, which is your new file system, and reboot to that. However, if you want to do a rebootless upgrade, you can use tricks like did I put it here? Yeah, Btrfs diff, which will give you an idea of what files changed. And I say most, and you can read why in the URL. It's not perfect yet. But the idea is, you know those files, then you can copy reflink them to the file system that you're currently running on, and that can be done in a portion of a second. And that way you get a rebootless upgrade of just the files that you need. The better way of doing this, though, will be to modify Btrfs send receive to only give you the list of files that have changed, because Btrfs send does that. So you can just use that feature to not send the data blocks and only send you the file names. So that is still something you have to write, but it's actually not that much work compared to this. So by the way, I don't work for Oracle, and not here, I don't make any money out of Btrfs, but I do really think that Btrfs is the file system that gives you the most features today that's built into the kernel, just because of Btrfs send receive, just because of snapshots, and that you really should give it a try if you have any use case that can benefit from it. If you use this in production, Oracle does offer support for it. They will find a version that they know works and say, hey, you can use that. SUSE is also providing Btrfs as a default for the next version, I believe, in OpenSUSE. As I mentioned, the other one, send receive, is mostly production ready. When it fails, I've had it fail on my laptop, it says, hey, I don't know how to do this, and then it just stops. So you don't have like reboots or corruption or anything, it just says, I had a problem, and if that happens, you just start over the copy and then it recovers from there. Block dedupe definitely needs work, so if that one is important to you, feel free to help out. And again, because even though Btrfs is technically experimental, it's quite usable. I mean, I use it on my main laptop with my main data that I really care about. I do have backups, but the point is, it's not just in a VM that I have no real data in. It's for real. As you may know also, Chris Mason, the author of Btrfs, got hired by Facebook. I'm just going to randomly guess that maybe Facebook has interest in using Btrfs in production, so that if the main author is working on this for them to be serving customers, you can probably hope that it's going to be even more stable and usable within a very short amount of time. So as the other two websites I gave you earlier said, 2014 is apparently, it may not be the year of the Linux desktop, which is the running joke, but it's hopefully the year of Btrfs. So why not give it a shot? And like Fujitsu, if you can contribute to it, even better. Thank you for that help. And now we have time for questions. So those are again the slides if you want the links. Totally unrelated, I got a bonus that I can give. If you work on open source and you want some free compute engine cycles, you can contact me. I can hook you up. And then questions. Yes?
You suggested some background motive why they created Btrfs from scratch. And your suggestion is patent problem with NetApp. And actually, when I first looked at Btrfs, I thought they were like trying to recreate open source version of NetApp. So do you think they had some intentionally list up Btrfs feature list referring to NetApp features?
So I am not a patent lawyer, but Network Appliance has I think 7 patents on specific ways of how they're doing copy on write. And my understanding is that Btrfs was written to offer similar functionality without using the same method. So Network Appliance cannot have a patent saying, I own all of copy on write. If any of you do it, I'll sue you. They can't do that. They just say, this is how we did copy on write And if anyone does it like us, then they're violating our patent. So because Oracle had a problem with ZFS, and because they settled, you would assume that if they settled that they probably were infringing as far as they were concerned. Then if they decide to write Btrfs, I'm going to assume that they're not stupid enough to rewrite the same patented code. Because then, you know, why, right? They might as well just get sued for ZFS instead of rewriting a file system. But I didn't read the patents, and I cannot say, hey, I'm a lawyer, you're okay, right? I'm just saying it's pretty safe that it's not going to be a problem because Oracle would get sued again if they did it wrong. And they're behind it, they're selling it as a product. So, you know, Oracle has some history of suing in patents, so I'm going to assume that they know what they're doing.
Thank you.
Yes.
Thank you for your presentation.
We have some employees looking at Btrfs, but I can't really tell you who's using it here or there. I use it on my workstation at work. I'm not the only person doing that, but that's all I know of currently.
Second and third question already answered from.
Okay.
Yes, thank you.
Okay.
Is it Warfarin? Thanks again for this session. In regards to, is it only data disks that you're using, like data files that you're using Btrfs for, or also OS?
Oh yes, my laptop boots on Btrfs. Like I gave a slide that shows you how to give the subvolume for the root file system.
Okay.
So my laptop boots with initRD. From initRD, it decrypts the device of my root partition, and then mounts the Btrfs root file system from there. And then I have a secondary drive. I have two drives in my laptop. My second drive is also Btrfs. So everything is on Btrfs. However, there's no reason to do that if you don't. You can use ext4 for boot, and for var if you want, and then you can use Btrfs for your data on a different partition. If you don't need snapshots and you want some data to be safer, if you feel that it's at risk, you could use ext4 for one and Btrfs for the other one. But I just like snapshots so much. Like let's say on my, I think it's what Suda is doing on the next version. That you can do a system upgrade of installing new packages, and you say, oh, it all broke. And then you go back to your previous snapshot, you reboot, and you're done. That's one of the reasons why they're using Btrfs, which is a lot faster than the alternatives. So that's also useful for that. But it's up to you. It depends on your use case.
Thank you.
Sure.
Do you have an example of how long it takes the Scrub to run?
Yes. How long does it take for Scrub to run? So I have a 1 terabyte SSD and a 1 terabyte hard drive in my laptop. They run overnight. It takes a few hours. It takes a bit longer on a hard drive, but it runs overnight. But I think it's not just how big your drive is, how many files you have, because I have to go scan all of that. I have I think an 8 or 10 terabyte array at home on spinning Rust, and that one has many files. We're talking like hundreds of millions, and that one takes longer. It takes a few days. So that one I run weekly. Yes.
You suggested you turning copyright on database or disk images, but it does keep safe, and how does Btrfs keep integrity of data without copyright?
That's a very good question, actually. I believe that's my understanding. My understanding is if you turn off copy on write, you lose the state of having the old file or the new file. You could be in the middle of a write. So you could have a half-written data block. Whereas if you use copy on write, if the new write is done, it's there. If it's half done, it's thrown away. And without that, you could have an incomplete write, which would not be great for a database.
Thank you.
Over there.
Could you tell me hardware recommend hardware specification for Btrfs?
Recommend what?
Could you tell me hardware specification?
Well, how do you?
Hardware specification for using Btrfs?
Hardware specs.
Memories and
Oh, the hardware specs.
Yeah.
Specification, I'm sorry.
Yeah.
Okay. Anything really. I mean, I use it on my laptop, I use it on the server.
Yeah.
It goes on pretty much anything. I think you don't want to put it on like a small, SD card. It works, but it's just, it kind of likes a bit more space than 120 megabytes maybe. But if there's actually a mode where if your device is too small,
Yeah.
it will mix data and metadata to be more efficient in space. So it even has a mode for that. So really, the answer is almost anything. And it doesn't take a lot of CPU resources. It's really, the only time it's expensive is if you do block deduplication, which is also very expensive in ZFS. But because it's not there yet, you don't have that
I
problem.
used to use ZFS. I agree with the ZFS. It's main memories.
Right. So no, it doesn't have the memory problem. And I think ZFS, if you turn off block deduplication, it's not as bad either. But if you turn it on, then it's expensive.
I should add some comments on the presentation about this ZFS. CDDA have many problems developing ZFS. So I used to contribute open source something development. So this CDDA finally licensed by Oracle. If anyone making some development, so
Right.
we want anything more. For these papers.
So CTDL is unfortunate. I mean, it's not even Oracle's fault, right?
Yeah.
They inherited that,
Yeah.
but clearly they made no attempt to fix it, because I think they're not interested in fixing ZFS anyway. I think as far as they're concerned, it's dead. They're using on Solaris because they're still selling that, but on Linux they have no interest in it. So it's unfortunate because it's really a nice file system. It has a lot of effort behind it,
Yeah.
and it's going to go get forgotten, in my opinion, just because of patents.
Thank you.
Unfortunate.
Last question.
So recently I've read about my question is recently that I've read about some patches that will try to extend ext4, so they will have some kind of snapshots capabilities. So what would be the advantage of using Btrfs over the ext4 plus the snapshots capabilities?
So I actually looked at that too, but that was last year. When did you read about it? Recently?
Maybe like 6 months ago or something.
Okay. At the time, I actually asked Ted, because he works a few offices down from mine when he comes visit. He didn't seem like it was going to get in at the time. That was a while ago though, because I also was excited about that. And so yeah, I didn't hold my breath is one. The other one is ext4 was not designed for that. So it's basically shoehorning, pushing more things in ext4 that it wasn't designed to do. So even if it gets in, it's not going to be as efficient because you really need to rewrite the entire file system to do it right. So it will give you half the feature, but without really doing it right. And it may be because of that Ted didn't take it. I don't know. I can actually ask him next time. But I think his answer on that is always, I want to keep ext4 doing what it does, do it right. And he's the one saying Btrfs is the future. He's actually saying that. But he also says it's 5 years from now. Because he knows it takes a long time to get a file system fully finished. So yeah, I would say probably not. And if it gets in, it won't work as well. All right. Well, thank you everyone.